Okay, so number 13, the table lists some compounds found in foods and their formulas. Based on the information, which of these statements is not true? A molecule of sorbitol contains 3 more oxygen atoms than a molecule of glutamine. Okay, glutamine, 3 oxygens, sorbitol, 6 oxygens, so that is true. A molecule of lactose contains twice as many atoms as a molecule of fructose. Well, lactose has 45 atoms. Fructose has 24 atoms. That is not twice. This one would have to be 48. So that is not true. Let's check the other ones. A molecule of fructose contains 4 more atoms than a molecule of glutamine. Glutamine has 20 atoms. Fructose has a total of 24 atoms. That is a true statement, which means it's not our answer. A molecule of lactose contains twice as many carbon atoms as a molecule of sorbitol. Sorbitol has 6, lactose has 12. That statement is true as well. So your answer, which one is not true, is B. Number 10, which statement correctly describes the location and charge of electrons in an atom? Guys, this is like strict memorization. Electrons have a negative charge, and they are in the electron cloud. You should know that right off the top of your head. All right. Electrons are inside the nucleus and have no charge. Wrong. Electrons are outside the nucleus. Yes, and have no charge. Wrong. Electrons are inside the nucleus. Wrong. And have a negative charge. Well, that part's right. The electrons are outside the nucleus and have a negative charge. There is the statement that has both parts correct. Number 26, a silver ring reacts with compounds containing sulfur in the air to form silver sulfide, a black substance that makes up the tarnish on the surface of silver objects. To remove the tarnish from the ring, students placed it in a pan lined with aluminum foil and added hot water. Baking soda was added to the hot water and stirred. Students made observations about the process. Which observation of this process provides evidence of a chemical reaction? Hot water heated the aluminum foil. Well, that's going to happen just simply because you poured hot water in it. The liquid solution changed color. Well, changing of color is most of the time an indication of a chemical reaction. The pan was lined with aluminum foil. So what? That doesn't indicate a chemical reaction. The hot water cooled. Well, of course it does over time, but that doesn't indicate a chemical reaction. Remember, the things that indicate a chemical reaction are formation of bubbles or fizzing, a change in color, a change in temperature that happens on its own, not because you heated or cooled something, and formation of a precipitate, and sometimes an odor change. So the only thing that works is G. Okay, just so I know you're paying attention on number 26, why don't you write down the 5 things that indicate that a chemical reaction has taken place. Temperature change, odor change, color change, fizzing or bubbles, and the formation of a precipitate. All right, number 30, which pair of properties describes the elements in group 18? We have talked extensively about the elements in group 18. They are known as the noble gases. They are extremely unreactive because they have a full outer shell of electrons. The only reason why atoms are going to react in the first place is because they don't have a full outer shell of electrons. So these guys already have all the electrons in their outermost energy level that they need, so they're non-reactive. They are called noble gases because they are all gases at room temperature. Okay, they're nonmetals, etc. Okay, they're going to be found all the way to the right of the periodic table, last column. They are chemically stable, yes, and liquid at room temperature, no. They have 8 valence electrons. Most of them do, except for except for helium, and are flammable. No, flammable would mean they're reactive. They are magnetic. No, they're not. And they boil at a low temperature. Well, they probably do boil at a low temperature because they're gases, but they're not magnetic. They are gaseous at room temperature, true, and are chemically stable. There's your answer, J. All right, number 23 says, a chemist made the table below to record some atomic properties of 4 elements. Based on the information in the table, which conclusion about the chemical reactivity of these elements is valid? Okay. Boron is the most reactive because it has the most protons. The fact that it has a certain number of protons does not make it reactive, so probably not. Fluorine is the most reactive because it has 7 valence electrons in its, well, I added the word valence, but 7 electrons in its outermost energy level. Fluorine is very reactive. It's the halogens. It's one of the halogens. It's very reactive nonmetal. Silicon is the most reactive because it has an equal number of protons and neutrons. That has nothing to do with its reactivity. Reactivity has to do with valence electrons. Gallium is the most reactive because it has many more neutrons than protons. Again, neutrons and protons do not determine reactivity. So even if you were kind of iffy about some of these, the only one that really makes any sense is the one that's talking about the fact that it only has 7 valence electrons and it would really like 8. Your very reactive metals are in column 1, all the way to the left of the periodic table. Your very reactive nonmetals are in column 17 or column 7A of the periodic table. That's fluorine, chlorine, bromine, and iodine, because they're looking around to get that one valence electron that they lack. So, 23B. Tell you what, just to prove that you're listening, go back and put halogens are column 17 and are very reactive. All right, final question. Number 21 says, a student listed how different parts of the body work to aid in the digestion of food. By the mouth, they said teeth tear and crush food into small pieces so that food can be swallowed. In the mouth, saliva is mixed with food to make food particles softer and easier to swallow. In the stomach, hydrochloric acid and enzymes help break down food molecules into smaller molecules. Which of the following is a chemical change that occurs to the food? The reduction in size of food particles as it is chewed. Chewing and breaking it into smaller pieces is a physical change. The movement of food to the stomach after the food is swallowed. Well, that's just taking it from the mouth through the esophagus down to the stomach. So that's physically moving it. That's not a chemical change. The breakdown of molecules of food by enzymes and acid in the stomach. You're taking big molecules and breaking the bonds, the chemical bonds, and making them smaller molecules. They're no longer the same molecules. That is a chemical change. Okay, none of the above, no, because we've got a chemical change listed. Okay, all right. Turn this in so that you can get your extra credit.